So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the topic of finding the area of a triangle when you're not given the height. Now when working out the area of a triangle, usually we'd use the formula of the area of a triangle equals base times height divided by 2, or another alternative of that formula is a half base times height. And that should always be your go-to formula whenever you're asked to work out the area of a triangle, so you're not making an easy question more difficult. However, what happens if you're not given the height of the triangle? And obviously with regards to the base, it's always the height, although you may think that the height and base of the triangle are sides of a triangle. That is the case if you've got a right angle triangle where the height is one side, which is this side here, and the base is another side. However, if you've got a non-right angle triangle, then the base of the triangle will be one of those three sides, but the height will be going from a perpendicular line from that side to the opposite point, and that would be your height there. So any of the sides could be the base, but whichever you choose, if you place that horizontally, that will be your base, and then the perpendicular height will be the line that goes from that line at a perpendicular angle 90 degrees to the upper point. Now when working out the area of a triangle, commonly and more often we will use the formula of the area of a triangle equals base times height divided by 2, or another formation of that formula, which is a half base times height. Now whenever you're asked to work out the area of a triangle, I would always check to make sure you can use this formula first, just so that you're not making a rather easy question more difficult. Now when it comes to this particular video, what we're going to discuss further is what happens if you're not given the height of the triangle. Now it's always when you're not given the height of a triangle, because commonly you will always be given the base of a triangle, and the base is basically one of the sides of the triangle. So the only time that would not be the case is if you've got a right angle triangle in which one of the sort of horizontal or vertical lines will be the height and the other adjacent side will be the base. And obviously we could rotate that, and so that this side, if we rotated it, let's say like this, then we would say this would be the base and that would be the height. Now obviously that doesn't apply when you're given a non-right angle triangle, where any of those sides could be the base, but then whichever you choose, if you lay that horizontally, then the height will be the perpendicular distance from that height to that opposite point. Now when you're not given the height of a triangle, depending on the information given and the type of triangle, we can use the following methods. Now for right angle triangles, always think of Pythagoras to find the missing side. So for example, if we're asked to find the area of this triangle here, as you can see we've got this side here, which looks like the height, and we've got this hypotenuse, or the opposite side to the right angle, which is 16. Now for this, what we need to do to work out the area is we need to work out what this length here is. Now using Pythagoras, the first thing we can do is label the sides, so A, B and C, and then using this formula we've got a squared plus b squared equals c squared, and that's Pythagoras theorem, and substituting the values I've got 16 squared equals 7 squared plus the base. Then if I work this out, I get 256 equals 49 plus b squared. Then if I do 256 minus 49 equals b squared, type that into my calculator, in which I get a b squared value of 207. So b squared equals 207. So to work out b, that's going to be the square root of 207. If I type that into my calculator, it gives me an answer of 14.428 blah blah blah, 328 I should say. Okay, and so working out the area of the triangle, then what we get is using base times the height divided by 2. The base is root 207, the height is 7, so the area is going to be 7 times root 207 divided by 2, and type that into my calculator. And again, you always want to try and be as accurate as possible, so rather than using 14.38, I'm going to use root 207, divide that by 2, and I get an answer of 50.356, and if we round that number up, I get 50.4 centimetre square, and that's to 1 decimal place. Now, if you're given an equilateral triangle or an isosceles triangle, think about halving the triangle to form two right-angled triangles, and then use Pythagoras to find the missing side. So if we apply this technique to these two triangles here, so in triangle A, we've got an isosceles triangle, and we've got the two same sides as being 11 and the other side being 8. Now, if I halve this triangle in half, this is going to be my base, and this line here is going to be my height. Now what we can then do, if I take that right angle triangle out, then what I end up with is 11, and that's going to be 4, and that is going to be h. So using Pythagoras again, we've got h squared plus 4 squared equals 11 squared. So h squared is going to equal 121 minus 16. So h equals the square root of 107. Nope, 105 it's going to be. And so working out the area of this triangle, it's going to be the base, which is 8, times the height, which is root 105, divided by 2. And if I stick that all into my calculator, I get an answer of 40.987. And if I round that number up, I get 40, well, actually it's going to be 41, so let's write that. It's going to be 41 centimetre square, and that's to 0 decimal places. Or you could say 1 decimal place, but then you'd write 40.0. Now for B, we've got an equilateral triangle in which those two sides should be marked. So that's going to be 6, and that's going to be 6, in which if I halve that triangle again, and I take this right angle triangle out, then this is going to be 3, and that is going to be 6, and this is my height. So using this triangle, we get h squared plus 3 squared equals 6 squared. H squared equals 36 minus 9. So h squared equals, that's going to give me 27. So h equals the square root of 27. So therefore, working out the area of the triangle using base times height, we've got base of 6, a height of root 27 divided by 2. And again, if I stick that all into my calculator, I get an answer of 15.588, and then rounding that number up, I get 15.6 centimetre square, and that's to 1 decimal place. Now for a scalene triangle, this is really higher level GCSEs. So for this, if you've not seen this formula before, this is a trig formula to work out the area of a triangle when you're not given the height. So for this, what we do is, you can see I've got the 3 things labelled. I've got 2 of the sides, A and B, and the angle that's created by those 2 sides is angle C. And this is the formula that you need to know. Now, this will be on the formula sheet, and so it isn't a formula that you need to know, but it's basically the area of a triangle, and it's part of the sine rules. And so if you've not done trigonometry, you will not need to use this formula. This only applies if you've been taught trigonometry. Now, substituting the values in, what we've got is, so if I just make up a scalene triangle, let me just make this up here, and any triangle that involves angles and sides is always going to be a trig question. So if I just make this into 50 degrees, let's just make up 2 numbers. Let's go for 12 centimeters, and let's go for 8 centimeters. Then here I've got a value of 12, a b value of 8, and a capital C value of 50 degrees. Don't know why I've written that, so let me just correct it. And there we go. So that's the information pulled from the question. And what I'm going to do is I'm going to substitute that into this formula. So the area is equal to 0.5 multiplied by 12 multiplied by 8 multiplied by sine 50. And if I type that all into my calculator, I'll get an answer of 36.770. And so rounding that number up, we get 36.8, and it's going to be centimetre square, and that's to 1 decimal place. So now let's apply these learnings into exam questions. Now, if you're wanting a copy of these questions, I'll include a link in the description so you can download it, have a go at the questions, and then maybe unpause the video or watch the video at this point, in which we can go through the answers. You can check to see if you're correct. So for question 1, it says work out the area of the triangle. Now again, with this question, we're not given the height of this triangle, so I can't use half base times height or base times height divided by 2. It also involves an angle as well. So I'm going to have to use the sine rule to work this out. So the first thing I would always recommend is labeling the sides and the angle, and then using the formula, which is not given to me in the exam but is given to me on the formula sheet, is using this formula here. So substituting the values in, I get half times 8.4 multiplied by 12 times sine 49. And again, if I type that all into my calculator, I should get an answer of 38.037 blah blah blah. And if you want to round it up or copy the answer, there's no indication in the question what it wants me to round it up to, so I'm just going to say 38.0 centimetres square, and that's to 1 decimal place. But if you have rounded it, always make sure you're stating what you've rounded it to. Moving on to question 2, it says which expression gives the area in square centimetres of this triangle. Now again, we're given an angle, even though it's called x. I can then use the sine rule to work this out. So I've got AB, which are the two sides that make the angle, and I've got C equals x. So again, using the formula of a half AB sine C, I've got A equals 0.5 multiplied by 8 multiplied by 10 multiplied by sine x. Now looking at this, it can't be these two because that involves cos. And working out the number part, I've got 0.5 times 8, which is 4, times 10, which gives me 40. So it's going to be 40 sine x, which is my second option. Moving on to question 3, it says the shape is made by joining a triangle ABC to the triangle with a diameter, semicircle with a diameter of AC. And the question is asking us to work out the total area of this shape. Now for this, what I need to do is if I label the two shapes A and B. Now for A, if I just take that shape out, so the area of A. Now area A is the triangle, so it's going to be equal to half AB sine C. And again, because we've got an angle involved, I know it's going to be using this formula. So I get 0.5 times 8 times 10 times sine of 114. And just notice that the sides are the same answer as the previous question, but not related. So here we get 0.5 times 8 times 10 multiplied by sine 114, and that gives me an area of A of 36.54181831. So I'll save that there. Now the next thing for us to work out in this particular question, now if you've not done sine rule or the cos rule, you're not going to struggle with this question. So this question is for higher level GCSE trigonometry. So for this, what I need to do is I need to find what this side here is. So if I just call this side x, and I take the triangle out and just do a little really poor sketch of that triangle. So I've got 114, I've got 10, I've got this as being 114, and that's actually 8. So let me just get rid of that. And this is what I want to find. Now to find x, what I need to use is I need to use the cosine rule. Now the cosine rule, which again is another formula that's going to be given to you, is this formula here, in which labeling the triangle, I've got this is A, this is capital A, this is going to be B, and that's going to be C. So substituting numbers in, I get x squared equals 8 squared plus 10 squared minus 2 times 10 times 8 times cos of 114. Now typing that all into my calculator, get an x squared value of 64 plus 100 minus 2 times 8 times 10 times cos 114 gives me an answer of 229.077. But I want to work out the value of x, so I square root that answer, and I get an answer of 15.1353 and 1839. So that is the value of x. So that means that the diameter of the circle, let me just write the diameter. So the diameter of the circle is 15.13531839. So therefore that the radius is going to be half of that. So if I divide that by 2, I get an answer of 7.56765997. Now the area of a semicircle is equal to pi r squared, so that's a full circle divided by 2. So from this, if I square this number, times that by pi, divide that by 2, that will now give me the area of the semicircle. So then all I then do, because I've still got that number still on my calculator, I can square that number, multiply it by pi, divide that by 2, and I get area B, which is the semicircle, of 89.9586664. And then all that's left for me to then do is add the area of A and B, so the total area is 89.9586664 plus, now that's still on my calculator, so all I then need to do is just add it to this number here. Now if you've done some rounding you may get a different answer, but here I'm getting 36.54181. Is it 831? Yeah, 831. And so plus 36.54181,831, and I get an answer of 126.5004847. So I'm going to write this answer as 126.5, and that's to 1 decimal place. Now if your answer is closer, if you rounded the area of A, rounded the answer of B, but you still added it together, you should still get full marks. As long as you've added some degree of accuracy, then that will be absolutely fine. Then moving on to question 4, it says the area of this triangle is 25 root 3. Work out the value of W. Give your answer in the form of A root B, where A and B are integers greater than 1. So again, this is a higher level GCSE question, and one that you can only do if you've learned the cosine sine rule, including the area of a triangle, and done a bit of surds as well. So for this, labelling this up, we get the area of the triangle. So area of the triangle is equal to a half AB sine C. So from this, what we can then do is substitute the values that I've been given. I know that 12 root 3 is equal to, and it's going to be x, or it's going to be a half, multiplied by A, which is x, multiplied by 20, multiplied by sine 60. Now sine 60 is an exact value of trig that we need to know, in which sine 60 is equal to root 3 over 2. So here I've got 25 root 3 equals, now half of 20 is 10, so that's going to be 10x, and then it's root 3 over 2. So that gives me an answer of 25 root 3 equals 10x root 3 divided by 2, so 25 root 3 equals 5x root 3, in which 25 must equal 5x, so x equals 5. Now from this I can then work out what the value of W is, because I can then use this cosine rule. So using the cosine rule, I've got this as being A, this is going to be capital A, this is going to be my B, and this is going to be my C. Now remember the cosine rule is equal to A squared equals B squared plus C squared minus 2BC cos A. And then from this, substitute the numbers in, I get W squared equals 5 squared plus 20 squared minus 2 times 5 times 20 times cos 60. Now cos 60 is another exact value of trig value, which is a half. So I get w squared equals 25 plus 400 minus 2 times 5, which is 10, times 20, which is 200, times 0.5. Now from this, what I can then do is work out w squared. So I join these up, 425 minus 100. So w squared equals 325. And what I want to do is then square root that. So w equals the square root of 325. I could then take out 25 as a common fraction, would simplify this, in which root 325 is equal to root 25 multiplied by, and again, if I then just work out how many 25s are in 325, that's 13, in which I get an answer of 5 root 13, and there is my final answer.